All right. Welcome to learning target number 5, the relationship between sine and cosine. You are probably to the point now through this unit of trigonometry and geometry that a lot of these sine and cosine and tangent things are probably starting to come a little bit easier to you now. So I am going to be able to speed through just a little bit. But remember, when we talk about sine, cosine, tangent, we actually remember the word SOHCAHTOA, where the sine of an angle is equal to the opposite divided by the hypotenuse, the cosine of an angle is equal to the adjacent over the hypotenuse, and the tangent of an angle is equal to the opposite over the adjacent. So given the triangle below, let's determine the following values. So I'm going to find my values first for x. So I'm going to find the sine of x and the cosine of x. So if x is my angle down here at A, then I like to find my HOA. H is the hypotenuse. It is across from B. So H is 5. O is the side that is opposite of my angle. So if I were to kind of shoot an arrow out of there, I can see the opposite side real easy. That is 3, and that makes 4 the adjacent side. Okay, with that being said, if I want to find the sine of x, we know that sine is opposite over hypotenuse. So this fraction here is the opposite 3 over the hypotenuse, which is 5. And if I wanted to find the cosine of x, then I do the adjacent side, 4 over the hypotenuse, which is 5. Okay. If I want to find the other thing, so if I want to find the sine of y or the cosine of y, then I actually need to get rid of all that stuff I see up there in blue, and I'm going to find my sides based on the y. So if my y is that angle up there at C, h is still across from 90, that didn't change. Over the opposite side is now down here, that is 4, which leaves 3 to be the adjacent. So if I want to find the sine of y, sine is opposite over hypotenuse. So y's opposite is 4, and the hypotenuse is 5. Cosine is the adjacent side, which we know is 3, divided by the hypotenuse, which is 5. So what do you notice? It says, what can you conclude from the results? Well, you don't even know what the angles are, x and y, and it really doesn't matter. As I look in this box of values, I can tell that the sine of x is equal to, which one's equal to 3/5? The cosine of y. And I can see that the sine of y is equal to the cosine of x. Well, that's really interesting, because here's what I do know about x and y. I don't know how many degrees either one of them are, but I do know that angle B is 90 degrees. So I know that x plus y plus 90 is a triangle, which has to equal 180. And if I subtract 90 on both sides, I know this. X plus y has to add up to 90. So those two angles, regardless of what they are, if x is 10, then that means y is 80. They're going to add up to 90. They are what we call complementary angles. These are called complementary angles. They add up to 90 degrees. So when I look back at my conclusion, as long as x and y are complementary, then the sine of one will equal the cosine of the other one. So we are now to the conclusion. It says from this we can conclude that if x and y are the measures of complementary angles, then the sine of one of them will equal the cosine of the other one. And you can switch the x and the y whenever you want. Another way that you can look at this is you can say that if theta, right here, that is the Greek letter theta, and theta just represents an angle measure. It says if there is some angle between 0 and 90 degrees, the sine of 90 minus theta would equal the cosine of theta itself. And if the cosine of 90 minus theta, that would equal the sine of theta itself. All right? So the big relationship that I need you to be able to see is the sine of 1 is equal to the cosine of its complement. So how does that help me in my examples? I'm going to do number 1 with you. This says that the sine of one thing is equal to the cosine of another thing. The only way this is true is if x and 25 are complements, if they add up to 90. They have to add up to 90. So x plus 25 has to equal 90. I can subtract 25 on both sides. So x has to be 65. So I'm actually going to check this in my calculator. X is 65. Oh, maybe I will. That's what I wanted. Oh, let me. Oh boy. There we go. That's what I was after. Okay, so if I want to do the sine of 65, this number better equal the cosine of 25. And since 65 and 25 add up to 90, you will notice that you get the exact same answer. All right, so it's a real easy way to check. All right, go ahead and try number 2 on your own. Use the same model as we did in number 1. You can press pause now. All right, as I take a look, the sine is equal to the cosine, which means that the two things, 80 and x, have to be complementary. If I subtract 80 on both sides, x would have to equal 10. And again, I'm going to check that using a calculator. All right, I'll do the sine of 80. And I'll do the cosine of 10. You will notice that they are, in fact, the same. Right, they are, in fact, the same. All right, as I get down to question number 3, 3 and 4 look a little bit more challenging, but again, they're not. I see that I have a sine equal to a cosine, which means my two angles have to be complementary. Well, my first angle is x. My second angle is x plus 10. If they're complementary, that means they add up to 90. So I just add my two angles together and make sure they equal 90. Well, x plus x is now 2x plus 10 equals 90. Subtract 10 on both sides, so 2x is 80. Divide by 2, and x is equal to 40. So we have up here, actually, the sine of 40 and the cosine of 40 plus 10, which is 50. And I can check that. Sine of 40, cosine of 50. So the sine of 40 and the cosine of 50. You'll notice that I get the 0.64278 number the same on both sides. And question number 4, go ahead and try that one on your own. You can press pause now. And you'll see that the sine and the cosine are set equal, which means my angles have to add up to 90. So I have x minus 45 as my first angle. X is my second angle. They have to add up to 90. They have to be complementary. So x plus x is 2x minus 45 equals 90. Add 45 to both sides. 2x equals 135. So x is equal to, what's that, 60, half of 135 is 67.5. Oh, that's right. Half of 135. Yep, a 67.5. So if I do the sine of 67.5 minus 45, that's my left side. And the cosine of 67.5, you'll notice again that I get the exact same answer. It keeps showing up again and again. All right, the next question says, in right triangle RST, first thing I'll do is DAP. It says angle S is the right angle. And it says the sine of R is 5x minus 8, and the cosine of T. Well, again, just like my last problem, this says that the sine of R is 5x minus 8. The cosine of T is 10x minus 28. Find the value of x. I know this, that the sine, I know that R plus T are going to be 90 because it's a right triangle. So that means that the sine of one is equal to the cosine of the other. So if the sine of R is 5x minus 8 and the cosine of T is 10x minus 28, the sine of one angle is equal to the cosine of the other angle. Now, some of you may be thinking, why did I not add these together and set it equal to 90? And that's because this problem is different. I said the sine of the angle right here, angle is R, angle is T. R plus T equals 90. I see that over here. Right? R plus T does equal 90. But the sine of R and the cosine of T are equal to one another. So I can set these two things equal. I'll add 28 to both sides. Give me a 20. And I'll subtract 5x on both sides. And then I'll divide by 5. And I'll get x to be 4. So be very careful on that problem, not to try to say that 5x minus 8 and 10x minus 28 have to add together to equal 90, because the angles add to 90, not the values of the trig functions. All right, make sure you're very, very clear on that. Number 6, this is one of them where I can see the sine of, this is right here. This is an angle. This is an angle right here. I see it because it's in the parentheses next to the sine. Let's compare that to the problem before. What is next to the sine? R. Okay, up here, you'll see an R is next to the sine. That's because R is the angle. All right, so the sine of one angle is equal to the cosine of another angle, so I see where the sine is equal to the cosine. So that means my angles, which are 6x plus 15, and 3x plus 30, those two angles have to add up to 90. Well, combining like terms, 3x and 6x is 9x plus 45 equals 90. Subtract 45, 9x equals 45, and then divide by 9, and x is equal to 5. The problem says find x and the values of the angles. So x is 5, which means my angles are 6 times 5 plus 15. Now that's 30 plus 15 is 45 degrees. And then 3x plus 30. Well, 3 times 5 is 15, plus 30 is 45 degrees. So these just so happen to not only be that the sine and the cosine are equal, it happens that the angles are actually the same as well. They're 45 degrees apiece. So I hope that helps you a little bit on the way. Again, the things to be careful of, make sure that when you are adding angles, that the angles add to 90. But if you are given the value of the sine of an angle and the cosine of an angle, notice in number 5, those are values of the sine of an angle, not the sine of a missing angle. So just be careful about where those variables are actually sitting. I hope this helps, and as always, if you have any questions, please don't hesitate to ask.